Hello guys, welcome to my channel. Today topic is about Malloc versus calloc. In the previous video, we have learned about library functions like Malloc, calloc, free and realloc library functions. This is the continuation of that video. In that video, we have briefly discussed about Malloc and calloc of library functions. In this video, I would like to explain what is the main difference between the Malloc and calloc. If someone was not watched that video, please do watch that video first and come to this video, because this is a continuation of that video. I will be placing the link in the below description. Please go through the link also. Malloc versus calloc. See, this is the syntax of a malloc, int asterisk ptr and int typecasting malloc function, and n is the size of the size which we have giving by the user into size of int. Just for regaining the knowledge of the previous video, malloc is a singular memory block. It means we are dynamically allocating a memory of a single block. Calloc, this is the syntax of a calloc. It means if n is 4 and size of int will be 4 here. It means 4 each blocks will be having a 4 size of bytes. Calloc will allocate a memory like 4 blocks with data type int means 4 bytes. Each block is having a 4 bytes. Clear? This is the syntax of malloc and calloc. It means n consider n as a 4 into 4, 16 bytes of malloc will be dynamically allocated in the calloc 4 comma 4. It means 4 blocks of each block is of 4 bytes will be allocated. That's the main difference between the calloc and malloc. See, these are the major differences of malloc and calloc. We'll be having like initialization. What is the type of how the malloc will be initialized, how the calloc will be initialized, how many arguments will be passed in the malloc function, how many arguments will be passed in the calloc, what's the return value of malloc and calloc, which is the better to access, whether malloc or calloc. We'll be discussing in the further slides about these main differences. These are the 4 major differences of a malloc and calloc. Clear? First differences, initialization. See, malloc allocates memory block of a given size in bytes and returns a pointer to the beginning of the block. The red, malloc doesn't initialize the allocated memory. See, in calloc allocates the memory and also initializes the allocate memory block to 0. It means, see, malloc and calloc both are used for dynamic memory allocation. And after creating a dynamic memory by using a malloc, we won't initialize to 0. It means just we will create a dynamic memory here and we will insert the elements which we are using here. But in calloc, after allocating a dynamic memory, first we will initialize to 0 into the memory blocks. Then after that we will be inserting the user inputs. Here, malloc will not initialize to 0 after allocating dynamically, but calloc will initialize to 0 after dynamic memory allocation done by using a calloc. Second point, if we try to access the content of a memory block before initialization, then we will get a segmentation fault error or maybe a garbage value. If you try to access the content of these blocks, then we will get a 0. See, after dynamic memory allocation by using a malloc, we are not initializing to 0. If you are trying to access this dynamic memory allocation memory with a pointer, we will get a garbage values or segmentation fault errors. See, but if you have dynamically allocated a memory by using a calloc, at this time, if you try to access the content of these blocks, you will get a 0. It means after dynamic memory allocation by using a calloc, we'll initialize to 0, right? Since we are initializing to 0 after dynamic memory allocation, if you try to access this memory, we will get a 0 in calloc. But in malloc, after dynamic memory allocation, we are not initializing to 0 anywhere in the malloc. That's why if you're trying to access this memory, you'll get a segmentation fault or maybe a garbage values. Depends upon compiler. That is the main differences between the malloc and calloc while initialization. Clear? Mainly this is like a short and simple I can tell. Malloc won't be initialized to 0 after dynamic memory allocation. Calloc will be initialized to 0 after dynamic memory allocation by using a calloc function. We cannot access malloc dynamic memory allocation. It means we can access the dynamic memory allocation which is used by the malloc, but if we access we'll get a segmentation fault error. But in calloc we'll get a 0 since it is initialized to 0 after dynamic memory allocation. Next differences. Number of argument. See, syntax itself we can see here. Malloc is having only one argument. See here, n into size of int. Size of int will be obviously 4 bytes for a 32-bit compiler. N will be the user size. User size which we are giving a input. Consider this as n as a 4. 4 into 4. 16 bytes of memory is allocating. See, malloc only is sending a single argument to the library function. See, by compiler by seeing the malloc here, it will check for the definition of the malloc in the header files. In that header files, it is malloc has to send some arguments, right? We are sending only single argument here. It means n into size of int I am sending here in the malloc. And compared to the calloc, see the syntax itself, we can see here two arguments n comma size of int. It means calloc is sending a two arguments. Number of blocks to be allocated, n is the number of blocks to be allocated, and size of the each block. See, and for suppose number of blocks to be allocated is 4 comma size of int is 4. It means 4 blocks will be having size, each of size 4 bytes. As we discussed in the earlier video, it would be very clear in this video. Please do what in previous video also. See, n comma size of int, it means we are sending a two arguments to the library functions. Clear? That is the main difference between the malloc and calloc while comparing to the number of arguments. In the malloc we will be sending only a single argument. In the calloc we will be sending all double arguments. Return values of a malloc and calloc. See, when dynamic memory allocation was done perfectly by using malloc either calloc, a pointer to the block of memory is returned. See, when we are creating a dynamic memory, when we are allocating a dynamic memory allocation by using a malloc or calloc, after allocation, successful allocation, it will return a pointer. The pointer will be pointing to the starting address of the dynamic memory allocation. Clear? This is the syntax as all we know. Into asterisk ptr, into star, this is the typecasting. See here, malloc after here I am taking a example as a malloc. Consider it as a successful dynamic memory allocation. Consider n as a 4 into size of it. 16 bytes of memory was allocated in the heap. It means there was no issue in the heap. It was allocating perfectly without any failure. That time, if the memory allocation was happened very properly, then malloc will return a void pointer. That void pointer will be typecasting to the int pointer, since we have taken as a int pointer here. This pointer will be pointing to the starting address of the memory which we dynamically created. Here, what it would be the same for the malloc as well as calloc. Return type. When we get a return type, we have to typecast based upon the return type we are taking here. See, what if the dynamic memory allocation was failed? But suppose we are trying to create a dynamic memory allocation. That time RAM was not accepted. But suppose heap was full of memory. It was not accepting us to create a dynamic memory allocation during runtime. At that time, both malloc and calloc will return a null value. Null value is written which indicates the failure of allocation. If the memory allocation was failed while we are using malloc either calloc, it will return a null value. This indicates the memory allocation was failed. Clear? That is the main difference. Which is faster to access? See, in the malloc, we might get confused, like both malloc and calloc functionality wise it was the same, only the behavior wise in the ram allocation, in the memory allocation, it would be a different. See, in that both, which is faster to access? See, malloc will be faster to access because we don't want to initialize to 0 after allocating a memory. In calloc, after allocating a memory we'll initialize to 0, it takes some time. See, in the calloc, after allocating a memory, we are initializing to 0 first, and then we are inserting elements depending upon our program. Correct? We are doing 3 steps. Dynamic memory allocation is doing, and we are initializing to 0, second step, and third step is we are inserting elements in the memory. Clear? But in malloc, we are dynamically memory is allocating, and the second step is directly inserting elements in the memory which we allocated dynamically. Since malloc is having only 2 steps, we are not initializing to 0. There is no step which includes initializing to 0. It means malloc will be very fast to access when compared to the calloc. Clear? Malloc will be very faster to access when compared to calloc. The only difference is calloc will initialize to 0 after dynamic memory allocation, but malloc won't do that. That is the main difference. While we are trying to access very faster, most of the people will be taking a malloc because we no need to initialize to 0. If certain situations we might to initialize to 0, that time we can use a calloc function. Interview questions. See, these are the few interview questions which will be very useful while we are attending an interview in C or C++. Mostly these are the C topics, malloc related questions, but it would be very useful in interview level. Mostly I am covering all the interview questions in every topic. Please do watch all videos. We'll getting interview questions in the last of my video. See here, what is the use of a malloc, calloc, free and realloc? See, these are used for dynamic memory allocation. These are the library functions we have discussed very clearly in the previous video. Please do watch the previous video. I'll be sharing the link in the description as well. Difference between the malloc and calloc. Yeah, in the previous slide we have discussed about a major differences. We have 4 major differences between malloc and calloc. Which is better to use in malloc and calloc? Most of the people will be use malloc, because since malloc is very faster access when compared to the calloc. What is the return type of a malloc and calloc? Both malloc and calloc will return a void pointer, and that void pointer will be converting into the will be typecasting based upon the input pointer. Which are the pointer we are pointing to dynamic memory allocation, that pointer only will typecast after malloc returns void pointer. What happens when we fail to do a dynamic memory allocation using a malloc and calloc? It will return a null value. If you fail to, while you are doing a dynamic memory allocation using a malloc and calloc, if dynamic memory allocation was failed, then it will return a null value. How we can free the memory without using free library? This I will be discussing in the next slide. These 3 points I will be discussing in the next slide. See, how does compiler knows how much memory it has to delete by a free pointer? See, if we are doing it with a free pointer, means dynamically memory allocated pointer we are deleting. It means we are deallocating the memory. But how does compiler knows this much memory has to be deleted based upon this pointer alone? We'll be discussing on the next slide this one also. What happens when we free the memory like free pointer plus 1? We'll be discussing the next slide. See, first interview question, like how we can free the memory without using the free library. You see, free function is used for deallocating the memory which we created by using malloc or calloc. Here, free function is used for deallocating. It means destroying the memory which we created for malloc and calloc. In this example, I have written a code by using, I'm using only malloc here. I'm using a malloc here. I'm taking int asterisk ptr pointer and typecasted to int pointer and malloc of 10. It means for syntax will be a n into size of int. I'm taking a malloc of 10 bytes. We have allocated a memory for 10 bytes here. If you use a free pointer here, we can directly destroy this memory. It means we can directly deallocate the memory which we created by using a malloc. If you use a free library function with braces ptr, clear? The free library function used for deallocating the memory. But without using this free pointer, free library function, how we can reallocate a memory which we created for malloc and calloc? That is the question, right? See, if I use a realloc, I'm using a ptr comma 0. That means here instead of 0, usually for the realloc its syntax will be like ptr pointer which we are pointing here. See, malloc is the dynamic memory allocation memory was pointed by this pointer. I'm using this ptr comma 0 will be for realloc is mainly used for increasing the size of already allocated memory. Usually realloc library function will be used for increasing the size of already allocated memory. Usually this is of 10 bytes, right? We allocated a dynamic memory of 10 bytes. If you want to increase the memory of already allocated memory, for suppose I have to increase 10 bytes to 20 bytes, then I can give a here 20 bytes here. N into size of int I can give a 20 bytes. It means 20 bytes of memory will be allocated. In that way, instead of giving a new size here, I am giving a new size as a 0 in the realloc library function. It means we are deallocating the memory which we created by using a malloc of 10 bytes. We create a dynamic memory of 10 bytes. We are resizing to 0. It means the memory was destroyed here. It means deallocated. Without using a free library function, we achieved this functionality by using a realloc. If any interview, someone is asking question like how we can free the memory without using a free library, we can directly answer like we can use a realloc and we can use a resize to 0. Then we can deallocate a memory to 0. A pointer is pointing to null means the memory is already deallocated. How compiler knows how much memory has to be deleted by a free pointer? See, we are clear that free library function is used for deallocating memory. By seeing this ptr, it will deallocate the memory which we have created with the malloc or calloc. Clear? But how compiler knows this much memory has to be deleted? Here, see, I have written a code here int main. I'm using a malloc 4 into size of int. It means 4 into size of int means 4 bytes of a 32 compiler. 4 into 4, 16 bytes of memory is allocated. 16 bytes of single block of memory is allocated. Clear? Here I am trying to free that memory. I am trying to deallocate that memory. Free, I am using a ptr. I am trying to free that memory. But how does compiler knows 16 bytes of memory has to be deleted by seeing this ptr? Here, but we don't know. We'll see the syntax and we'll see this library function. Just we are blindly keeping a ptr here and freeing that memory. We are aware of that what is happening by in front, but we don't know what is happening in the back end thing in the library function. See here, while we are allocating a memory here, extra 1 byte of memory will be allocated. Suppose I am dynamically allocating a memory 4 into 4, 16 bytes of memory during runtime. While creating dynamic memory here, 1 extra byte of memory will be created. It is used to store the total memory of, it means total size of this memory. Suppose we allocated a 16 bytes of memory single block here, right? In extra byte it will store the size of this memory 16. From this extra byte the compiler will check, understand the size is ptr is of 16 bytes, then it will send the library function it will send to library function as 16 bytes. Then compiler will decide it has to free the memory of 16 bytes. Clear? While we are allocating a single block of memory, in the heap, one extra byte will be allocated for storing the whole size of a malloc dynamic memory. In the extra byte, it will store a 16 bytes. From this extra byte only, the compiler knows it has to be deleted 16 bytes of memory. Here, see, this is the consider above example. While allocating a memory in heap, one extra space will be allocated. This means extra byte memory size. Consider this 4 into 4 is of 16 bytes. Clear? In this extra space, it will store the size of pointer. In the extra space, it will store the size of pointer. The size of pointer means size of pointer which is pointing to the dynamic memory. It will store the 16 bytes. Then compiler will understand it has to be deleted 16 bytes of memory. That's the explanation of this, how compiler knows how much memory has to be deleted by free. You can directly answer like the compiler, while allocating a memory, one extra byte of memory will be created for storing the size of this particular pointer. What happens when we free the memory like free PTR plus 1? See, when we are entering an interview, this is an important question I feel, because see, this is like a critical, it's a, like a different type. We never thought like deleting this. Like, see, I'm taking a example program here. I'm using a malloc here, int star and a asterisk malloc 4 into size of int. It means 16 bytes of memory is allocated. Here I'm using a malloc, 16 bytes of memory is allocated, and malloc is returning a void pointer. I am typecasting to a int pointer since we are taken a int pointer here. See, free is used for deallocating memory, right? But here I am trying to deallocate memory by PTR plus 1. It means I am trying to add 1 to the already existing address. Consider like we have created 16 bytes, and the first byte the pointer will be pointing, this PT pointer will be pointing to the for starting of this dynamic memory allocation. That is clear. But while we are deleting, we are deallocating memory, we are trying to add 1 to the address of this pointer. It will throw an error. We cannot do this type of a deallocation. The compiler won't accept. Library functions are built like it has to delete only the memory size, but we are trying to increase the size of address. It will throw an error. It will throw a compilation error. We cannot free the memory. See here, we cannot free the memory like the above. It will throw an error, or sometime it might crash, since we are trying to add 1 to address and trying to free it, which is abnormal. It will be an abnormal behavior. We cannot free memory like PTR plus 1. It will throw a compiler error, or it will crash. Depends upon the compilers. If interviewer is asking question like what happens when we free the memory like free PTR plus 1, we cannot do. This is a abnormal behavior. The compiler behave like abnormal. That is the main answer for this question. This is a very important question in the interview. Even I have faced this question. I hope you all guys are very clear about this topic. It is way so far, and please do what previous video also. When you are coming to this video, it would be very really helpful. So far I covered all the topics of malloc, what is the difference between the malloc and calloc, and what are the library functions, and interview questions also. And I will be placing in the description also these interview questions as well as the previous videos, previous video links also. Please do watch that videos also. It will be really helpful. Thank you all.